one. Hello everyone, welcome back to another video here at Becoming a ROS Developer, the Construct. My name is Rodrigo, and today we have one of our students, Pruthvi, who has finished the course ROS2 Navigation in 5 days. And at the end of this course, you can present your project that we offer in order to get a certificate and to showcase your learnings. And that's what we're going to be seeing here today. So hello Pruthvi, how are you?
Hello, sir. I'm doing fine. How are you doing?
I
It's
am
really good
doing,
to meet you.
thank you, you as well.
Yeah,
I am doing well and very excited to see your project. So please, whenever you
yeah.
want, start sharing your
Okay,
screen and just tell us how you've accomplished it.
okay. Um, Let me just share my screen.
Great, we can see your
Uh,
screen now.
Thank you. Um, so I'll just start with a basic presentation on how this ROS2 works. ROS2 navigation works. So the ROS2 navigation, it's the project involves mapping, localization, path planning, obstacle avoidance, and navigation. So we start with first mapping the uh, robot. So mapping is an operation of a robot. So it basically requires three nodes here for this project, which is the map server, AMCL, lifecycle manager, and robots use mapping in general for the following, which is to localize and to plan trajectories as well. The next part is localizing the robot. As I mentioned before, after mapping, we go for localization. We call a robot to be localized when a transform is published between a map frame and an ODOM frame. And we use the AMCL, which is the Adaptive Monte Carlo Localization. So AMCL generally uses particles to localize the robots, and each particle having their own coordinates. The next part is the path planning. So generally, what path planning means is that planning a trajectory from point A to point B. Uh, and while uh, the bot follows the trajectory, it might also involve uh, avoiding obstacles. We use the 7 nodes for path planning, which are the nav to map server, nav to AMCL, planner controller, recovery behaviors, behavior tree navigators, and the nav to lifecycle manager, which is pretty much explained when the course is done. And we also use obstacle avoidance, and what we use for obstacle avoidance is the global cost parameters and local cost parameters, and an obstacle layer was also added, so in order for obstacle avoidance. So yeah, I think it will be better understood if we get into the demonstration.
Yeah, awesome
Yeah.
presentation, really clear. Yes, let's see it in action.
Yeah. Okay, where's my option? Yeah. And yeah, I'm able to control the robot. So as you can see,
Great.
I'm connected to the robot. Okay, let me just start with this. Meanwhile,
Make sure you're in the workspace.
yeah. Uh, I usually build it once outside the workspace and then I open the work.
Oh, that's
Yeah,
nice.
just
Okay. Yeah, I was
yeah.
gonna say, well, how did it detect your packages? All right. Yeah, cool. I see what you're doing.
Yeah. And meanwhile, I'll just oh okay. I'll just open my config. Okay. I'll start with launching the localization.
Mm-hmm. I think you're missing ROS too.
Yeah. Oh, yeah. Sorry. Yep. We should have it. One second. It's just too small. Uh, okay. Mm, Okay. I'll start the path planning. Is it not localized?
Did you provide a initial estimate?
Yeah.
There we go.
Yeah. Yeah. There you go. That took some time. So as you can see over here, we have the nodes just clustered around, and it's not very specific.
Mm-hmm.
And so, um, is it in the right direction?
I think it was 180 flipped. That's
Oh,
why it seems unlocalized,
yeah,
I believe.
yeah, exactly, yeah. Um, okay, I'll just turn it. Okay, I think it should be right around. Yeah,
Mm-hmm.
there you go. We're able to see the uh, the nodes clustered at the right
Yes, quite
location.
clear.
Yeah, and then the next uh, after the path planning is done, uh, I've launched the path planning. We can start providing the commands for moving to the specific nodes. So I have three spots which I have where I'll be navigating the bot to.
Okay.
Um, so I've named them a pedestrian corner one and corner two. Um, and right now we should be able to see the bot moving to the pedestrian spot. Um, okay, where's Avis? Okay.
Nice.
Yeah, now we just try moving it to corner one.
Uh-huh.
Uh, I'll just give you a, oops, wait, the screen just went blank.
Oh, that's weird. Maybe by minimizing it and open it again. Oh, there
Oh,
we go.
yeah, there, yeah. Okay,
Something strange happened there. But I mean, we
yeah.
don't precisely need
Okay,
Arvis
Avis,
to
okay.
see it.
Yeah, that's true. Okay. And we'll try moving it to corner one.
Correct.
Just a second. It should be name is equal to one. Let's just. Okay, yeah. Wait, it's not moving on?
So I think it might be too close to an obstacle or something. So if you were to
Okay.
show the
Okay, I'll just.
yeah, if you were to show the output of your navigation, you would see goal
Okay.
failed or something.
Yeah.
I mean, that should be all right.
Yeah, I think here it should be fine. Oh yeah,
Yeah, you see?
there you go. It moves to, yeah. We're able to navigate it to corner two, um, which is at the right bottom corner. That's where those are the coordinates provided.
Mm-hmm.
And uh, I would- I also want to demonstrate corner one, so we'll go for that next.
Yeah, you see how it's attempting to reach there
Yeah,
the area.
yeah,
So maybe
exactly.
there's a little bit of
An
a
obstacle.
no. My guess is
Mhm.
that for some reason there's like a little bit of an offset towards your right
Yeah, that's true.
there. So
Yeah,
you can
yeah,
stop this.
yeah.
And if you send it to corner one, it's probably not gonna start because it's on
It's not
top.
gonna start.
Let's see.
Yeah,
Let's see.
exactly.
Maybe it's.
Yeah, it should. I mean, we can try, but yeah, that's the offset. Yes. Um, so I think when it's really close to an obstacle, it takes in during the mapping. It's like it tries to avoid obstacles in the during the mapping phase, and I think that's a major you know the major part of the robot's movement is controlled. Is controlled, and it's to avoid the obstacles.
Mm-hmm.
So um,
So it sent out
yeah.
the goal that you sent. It
Oh,
still
right, the
got
previously, or
registered.
once I moved it, yeah,
Yes.
exactly. So it goes to corner one right now. Okay, yeah,
Nice.
yeah,
All right. Is
and
that your whole demo?
yes, yes, sir, that's it.
Awesome. So really nice, Prithvi. Congratulations. So let me give you a little
Thank you,
nice little applause here. Really
thank
clear.
you,
I liked how you started with the presentation, clearly
thank you.
stating, the components of nav2, which means you understand uh, the main components and what you need to do. I really like that you specified actually. Um, a robot is localized when there is a transform from map to autumn. That is the most crucial part of, for example, AMCL to understand, um, and it helps a lot while debugging things. So it's the main thing you got to understand, at least in this application that AMCL publishes that map. And sometimes you don't have to, but the default and the most common used is publishing that. So I really like that.
Yeah,
So uh, and then also I noticed that you have a nice little launch file there for your client, for your nav2 client calls.
hmm,
Your navigate. Suppose you have a launch file there that you just add an argument to the spot name that you need to do.
exactly, yeah,
That is very nice, and it takes a little bit of extra effort to do that in the beginning. But I really
yeah,
recommend everyone, and a good job for you to do this, because this way you can just it makes your life a lot easier, than having to um, do it directly from the executable.
yep,
I really like that. So good
exactly,
job on that. And I have
yeah,
basically one comment and one question, one recommendation.
okay,
And it's not related
okay,
to nav2, but more
hmm,
related to ROS2. And it's the comment I made about you building on the root source and then
okay,
in your
on the workspace,
workspace. I do not recommend that
okay,
because uh, there's no reason why you should compile in the root space,
outside,
because
yeah,
you should have everything contained, and
yep,
uh, I believe that it can lead to confusion. So always make sure you're compiling in there and you don't have built-in install folders everywhere. It's just
yep,
a recommendation, because then versions start to change, things like that, and it takes a while to figure out what's going on. And
okay,
the one question I do have about your application is basically, how would you avoid the scenario we saw in the video, that the robot ends up in a place where it cannot get out of?
yep. Um, So probably the mapping is where we must focus even more, because the main reason, like even when I was working on project, obstacle avoidance was like one of the major difficulties that we had to overcome in this project. So in order to avoid it, I'd say maybe increasing the number of nodes. So in order to get a more precise location, the offset is becomes minimal. Is something I would recommend. Um, or we could also try and um, maybe we can try controlling the movement of the bot better. You know,
Mm-hmm.
it's because yeah, I think these are the two solutions that I can think of right now. But probably there are other ways in which it can be done.
Right.
Um,
So
yeah.
let me mention this. So just so you know,
Uh-huh.
there's a combination of things. You were right about maybe the coordinates you took were at a moment where it was mislocalized, but
Yeah.
so we were that's what the shift we were talking about. But
Yeah.
usually you can do this all in the configuration, right?
Yeah.
So
Yeah.
the with a very well configured nav2 stack, you would never run into the scenario where a robot ends up on top of an inflation radius that will prevent it from getting out of it. So a
Yeah.
couple things you can check all the time is first your controller frequency versus your speed of your robot, right? Because maybe that
Uh-huh.
creates an overshoot situation that is too, it's makes it go on top of that inflation radius. So that's one thing.
Yeah.
Another thing is
Yeah.
to see what your robot radius is and whether or not it actually coincides with the size of your robot. So maybe in that case it was a
Okay. Yeah.
little
That's
smaller. So once we jumped in there, um, it was that issue. And the other thing I recommend is basically making it a little slower. And um, I did not see any recovery behavior kick in once it was in that situation. So
yeah.
uh, we got to make sure that you do have those kick in, and if not, investigate why. Because I know why, for example, it didn't go the backup behavior
Exactly.
because it's on top of a inflation layer, so it can't
Yep.
really tell it move. But I think you can, even if that's the case when you're on an inflation rate, I think you can make it rotate. So that could be
Exactly.
another
Yeah.
thing that could help
Yeah.
out. So
Yeah.
I recommend you take a while to see if you can kind of detect these cases because at the end, and you want to trust NAF2. You want it to just start sending goals everywhere and trust that it's going to arrive to its goals. Also, the
Yep.
tolerance, all important, how tolerant you
Yep.
want the goal.
You. Yeah.
Um,
Exactly. Yeah.
but anyways, Prithvi, that's all the comments I have. Other than congratulate
Okay.
you again for a
Thank you.
very nice presentation and demonstration on the real robot.
Thank you. Yeah.
All
Thank you so
right.
much.
Well, let me
Yeah.
just go back here to myself and tell you, everyone that is watching, that you can do the same here that Prithvi did here, and present what you've learned in our courses in order to get your certificate and just solidify what you've learned with us, because it's very important to us to know that the students are actually taking something from our courses. So thank you very much, everyone, for watching. And thank you, Prithvi, again. We'll hope to see you again very, very soon.
Thank you. It's been a pleasure, and it's been an exciting journey to complete this navigation course, and I would strongly recommend to anyone who's watching this.
Great. I'm glad to hear
Thank you.
that. All right, guys,
Thank you.
that is all the time we have. So we'll see you guys next time for the next presentation. Bye bye.